All right, here we go. We've got a little bell work here, and you know I don't usually like doing bell or don't always do bell work, but I do like to do bell work when I feel it is important. So here we have BC and BD are angle bisectors, not trisectors, and really we should have had this in the directions. BC bisects angle ABD, and BD bisects angle ABE. All right, but it wasn't written in there. My apologies. So I jotted it down. If angle EBA is 130, or angle ABE, we can write that backwards. Find the measure of angle ABC. So just this little guy right here. Okay, so let's start doing some work. I'm going to go ahead and go with, let's go with some green. Green's my favorite color. Okay, so if EBA is 130, then that would make each half, because it's bisected, half of that, which would be 65 degrees. And we know that those two angles are congruent due to bisecting. And let me put that tick mark maybe just slightly off of the line so you can see it better. Okay, so both of those are 65. Well, then BC bisects angle ABD, doesn't it? So it's half of that. Well, what's half of 65? It would be 32.5 degrees when we cut that in half. So that would be the measure of angle ABC. Cool. Not too bad. All right, now it says measure of angle X is 2x minus 5. This is a separate question. separate question. If angle X is acute, what are the restrictions on X? So it's acute. Well, what does that mean? Oftentimes people are like, oh, well, that means it's like 89 or less. What about 89.5? That's still under 90, right? So really we have to set up a compound inequality. X is, well, the angle, which is 2x minus 5, that's its measure algebraically, is going to be less than 90 degrees, right? It could be 89.9999999 and still be acute. Now, if it's less than 90, can it just keep getting smaller? Can it go negative? No. So it does need to be greater than 0. And now we can solve this wonderful compound inequality. So I'm going to add 5 to both sides, or excuse me, to all three parts. That's exciting. That one's gone, and I'm left with 5, 2x, and 95. All right. So if I divide everything by 2, and I'm running out of room, so I'm just gonna do it. We get 2.5 over here, x, and then 95 divided by 2 would be 47.5. And those are my restrictions on x. Awesome. All right, so big thing to remember there is when we're dealing with acute, they're between 0 and 90. Obtuse is between 90 and 180. Don't go to like the 91 and 179 or the 1 and 79, or sorry, yeah, 89 type of thing. That's where mistakes tend to happen. All righty. So totally different topic, probability. But we're going to do probability within geometry. Okay? So big thing with probability is we're going to list the important steps. There's two important steps. We're going to list all the possibilities, and we're going to circle the winners. Some of them you need to like write it out like that. Some of them you can, simple like flipping a coin. You 1 out of 2 to get heads or 1 out of 2 to get tails. But some of our probabilities are going to be a little more complex. So again, if you want to jot something like that down, winners over total possibilities, or like what we want to happen over the total possible outcomes. Okay, so this first one, it seems to mess up the rays. So this is a ray. If a point is randomly chosen from the diagram below, what is the probability that it lies on triangle EGC? So that would be EGC right here. Okay. Well, first off, how many total points are there? There's A, B, C, D, E, F, G. That's 7. I count 7 on my fingers. Okay, so out of 7. Now, how many points are on that triangle? Well, we think first 3, but that point F right there, 4. 4 points are on that triangle, so 4 out of 7. Okay, what's the probability that lies on DF? Well, if I start at D and go in the direction of F, it continues on through C, so I end up with 3 total points out of 7 on that one. And then lastly, it lies on angle GAD. Okay, well, GAD is made up of two rays with a common endpoint of A. So really I have 1, 2, 3, 4, 5 out of 7 for my probability there. Awesome. So remember, knowing that an angle is made up of rays is very important here, right? Because that continued on and ended up including 2 more points. So knowing what things are made of, very, very important. So here we have a point Q is randomly chosen on AB. What is the probability that it is within 3 units of C? Okay. Sorry, why did I say 3? 5 units of C. What is Mr. Allen saying here? All righty, a point Q. So let's see. We're saying that it's within 5 units of C. Well, how long is this whole segment right here? From 3 to 15, we're looking at a length of 12 altogether, right? Now, if I can go 5 units in this direction, that's 5, and I can go 5 units in, oh wait, hold up. I can only go 4 units to that way. Otherwise, I'm off segment AB. So really, I can only span a total of 9 out of the 12 total length of this segment, which would simplify down to 3 out of 4. Excellent. All right, time for some the clock problems. These are always a little bit tricky. First off, you have to remember how to tell time on an analog clock, which is just crazy for some people. So we might have to have a whole lesson on that itself. So the second hand of a clock sweeps continuously around the face of a clock. What is the probability that at any random moment, the second hand is between 7 and the 12? Okay, so let's go ahead and draw a clock. I'll go blue. And we'll go to the center there. And when is it between the 12 and the 7? So we got a 12 up here, 6 down here. I won't do the whole thing for the sake of time. All right. Or wait, watch this. Boom. It's like magic. Just hit pause. All right. So between the 12 and the 7. So when is it between, as it goes around, between the 12 and the 7? Or between, 7 and 12. So we're going like that. All right. Well, we're saying continuously around, right? Continuously around. So if you break the clock up into 12 sections, right? How many sections do we have here? Well, I've got 1, 2, 3, 4, and 5 out of 12. Voila. Excellent. We'll think of it as like, I know some of you are like, oh, what if it's on the numbers or whatever? We're talking about a continuous motion, so divide up into 12 sections. Lovely. We have some other fun clock problems that I remember during the year here. All right. If 2 of the 4 points are selected at random, what is the probability that both lie on ray AC? All right. Well, let's see here. This is one where we need to write some things out. First off, ray AC is that. Okay, that's good to keep in mind. And it says 2 of the 4 points are selected at random. So let's think about our choices here. I could choose A and B. Normally we put, I guess we could just put a comma between them. We could do A and C, and then A and D. So I don't want it to look like a segment length, so I'm putting a comma. Then we have B and C. B and D would be another pair, and then C and D. Anything else we'd be repeating, like D and C is the same as C and D. We're just saying, we're not saying that the order in which they're picked matters. Okay, it's just that these 2 are picked. So how many possibilities do we have here for pairs of points? Well, we've got a total of 6. All right, so our denominator is 6. Now, how many of these points are the winners? Well, they have to have A, B, or C, right? 2 of those. So this one's good. This one's good. Nope. This one's good. And those are not. Okay? So 3 out of the 6 are bueno. It's a different color blue. My goodness, that might bother somebody. Okay? Which would simplify down to 1/2. I love it. Excellent. So when we start talking about these pairs or groups of three, you need to write them out to really get an idea of like what's happening in the problem. Okay, you will see one of those on a quiz. I think you'll see one in the homework as well. Alrighty, so let's try one more of those. It says if two angles are chosen at random, what is the probability that they are both acute? All right, well, which angles are acute? We got A and C. Those guys are the acute angles. B is a right angle. It's noted, right? We can assume that that's a right angle because it's marked. Okay. The other two have to be acute. How do I know that? Well, there's 180 degrees in a triangle, and if 90's already been used, then the other two are going to add up to 90. They have to have something, so they're going to be like 89.9 and 0.1, or even smaller than that, or somewhere in between. Okay. So they have to be acute. So let's list out our angle pairs. So I'd have angle A and angle B, angle A and angle C, and then I'd have angle B and angle C. And I guess that's really about it. So 3 total options here. We're choosing pairs, right? Well, which ones are acute? It looks like the only one that's going to work is both acute. So 1 out of 3 is our chance. Cool. Some people will be like, oh, it's 2 out of 3 because there's 3 angles and 2 of them are acute. Well, no, it's how it's worded. We're choosing 2 angles at random, 2 of them, and what's the probability that they're both going to end up being acute? All right, awesome. Big fan of that one. I hope you guys enjoyed chapter 1 here, and look forward to reviewing it all and having a wonderful, wonderful assessment. All right, you guys have a great day. America, freedom, rock and roll. Costco, stay hydrated. Peace out.